know what is the comparative advantage, we know what is the opportunity cost, what is the PPF curve. Now we have the tools to start with this model, with the Ricardian model. We are going to start with the easiest framework. So one factor economy, so just one economy. And that economy, we are going to call that economy home. In that economy, the only production factor is going to be labor. And the differences in terms of production are coming from technology. Just keep in mind that for Ricardian, the thing that he wants to analyze is the effect of different technologies across country in a really simple framework with just one production factor. So we are going to consider only two goods. So each economy, here just one economy, this economy is able to produce only two goods, cheese or wine. So the whole range of possibilities now is smaller, just two goods. Okay. Also, it's important that the supply of labor is going to be fixed, okay, constant. We have an amount of labor and that's it. We don't have the opportunity of people coming from other economies and be part of our labor, okay? Or neither people from our economy go outside. No, it's fixed, okay? Also, interesting, it's going to be that the productivity of labor is going to be fixed in each sector. Here we have two sectors, okay? The sector of cheese and the sector of wine. And that productivity of labor is going to be fixed and is determined by the technology. Okay? So given the technology that we have in the production of cheese, we are going to have one productivity of labor. And given the technology that we have in the production of wine, we are going to have a different productivity of labor in that sector. So the same worker, given the technology in each sector, is going to have a different productivity. And it's going to be always the same value. Also, an important and a final remark, we are going to assume that the perfect competition prevails in all the markets. So that means that the price of each production factor or good is the marginal cost. You should know what is the meaning of that, given the fact that you have already know something of economic coming from the previous course, okay? This is perfect competition, okay? When the price is equal to the marginal cost. So one of the assumptions was that the productivity of labor, it was going to be specific for the sector. For each sector we are going to have one, and it's going to be constant. How is the way of introduce that? With this concept, okay? Unit labor requirement. We are going to indicate that with this A vocal. So, what is the unit labor requirement and why that is connected with technology, productivity or something like that? Unit labor requirement is the number of workers that you need to produce one unit of something. So here in our example that we are going to do, we are going to have one unit labor market for the case of wine, another for the case of cheese. This number 2, for instance, that means if you want to produce 1 unit of wine, you need 2 labors. So that is the unit labor requirement. How many workers, labor, do you need to produce 1 unit of that good? So it's going to be specific by the sector. It's not the same value for the case of wine than for the case of cheese, and it's going to be constant. It's just a number, it's not a function, so it's going to be constant. Because here we just have labor, we can miss the L, okay? This L is coming from labor, while the other letter is coming from the sector of wine and the sector of cheese. So instead of this, we can use just this one. So, why is technology behind? Because the productivity is determined by the technology. Here we are observing that the technology for producing cheese is better than the technology for producing wine. Why? Because this value is lower than this. So in the cheese industry, given the actual technology, you just need one worker to produce one cheese, while here you need two workers to produce 1 unit of wine. Okay, something else. Okay, another thing it was that the labor, it was going to be the only production factor, and also that it was going to be fixed. Let's put a number here, why not? For instance, it's 120. With this data, we are going to elaborate the PPF course, and then we are going to get the opportunity costs of cheese, of course, and then in the case of wine. But before, I want to show you something interesting. That is the fact that the inverse of the unit labor requirement in the case of any sector is going to be, or the inverse of that value is going to be the productivity of labor in that sector. Remember, this is the number of workers that you need for 1 unit of production. As higher is this value, the productivity of labor in that sector is lower. It's like you need more workers just to produce 1 unit, no? As higher is this value, the unit labor requirement, that means that you need more workers to produce 1 unit. So that also means that, has the implication that labor is with a low productivity level. So we have the productivity here. We are going to get this value in a different way, but I just want you to show you that now we can observe also the productivity of labor, just doing the inverse of that value. So the productivity of labor in the case of the wine sector is 1 over the unit labor requirement in that sector. So as higher is this value, like you need more labor to produce 1 unit, is because the productivity of that labor is smaller and smaller as higher is the value. The same thing for the other, of course. So the unit labor requirement is not something good, having a high value in that concept, because means that you need a lot of workers. So, and that is because in that sector labor is not really productive. So as higher is that value, lower is the productivity, because it's just inverse numbers. So as higher is this one, the whole thing is smaller, and that is the productivity. So now, with those numbers, I think they are right. I'm sure. We can do the next thing. So here I'm going to start with the formula, in the most general way, okay? Just with the letter instead of numbers. So we know that the labor is the only production factor, and also it's fixed, so it's going to be a number. This is labor, okay? We use L for labor. Also we have the unit labor requirement of cheese, the unit labor requirement of wine. So that's that is going to be also a number. It's here just A, and then we are going to put numbers. It's a number, and that number is the number of workers, so the number of labor that you need per unit of production. So that's why you need the production. So here we're going to have number of workers that you need for 1 unit of cheese multiplied by the number of cheese that you want to produce. So the whole thing here is the number of workers or labor that is going to be in the cheese sector. And the same thing for the case of the wine sector. So number of workers that you need for 1 unit of wine multiplied by the number of units of wine. So number of labor that is going to be in the wine sector, and we know that this plus this always is going to be that value. Why is not going to be a smaller value? Because we are looking for the PPF course, so the production possibility frontier. That means when we are using all our resources. So lower, if this is lower than this, it's because it's not efficient. That means that it's like we have potential to produce more, because we have more workers than the ones that we are using. If this is higher of this, something is wrong, because that is not possible. It's not feasible. It's like being here outside of the PPF. And as we said, that is not possible. So always has to be the same, because just by doing that, we are getting all the possible combination of the production of wine this Q is for quantity of wine and the production of cheese that are feasible or possible, but also is efficient. So when we are using all our resources in the way that if we are in a point like this and if we want to produce more one of them, we by sure need to reduce the production of the other. Okay, so that is the PBF. This is a key general function. Now, using our data, if I don't remember wrong, we have that the Unilever requirement in the case of cheese it was 1 and 2 for the case of wine, okay? And our labor it was 120. That is the thing that we have. This is the constraint and we want to draw that in our graph. That is going to be the PPF, okay? So to do that, the easy way, because this is a straight line, so with 2 points is enough. The 2 points, the most easy way of getting that is the strain cases in which one of the variable is 0 and look for the other and vice versa, okay? So here I'm going to do this. I'm going to isolate one of the 2 variables that we have. So here is the quantity of wine. That is going to be this value, okay, quantity of 1. To get that value is like this term with this positive sign goes to the other side with the negative 1, okay? 1 is 1, so it's like this value, that's why I introduced that. And this, which is multiplying, is going to be, is going to the other side dividing. So that's why here we have the 2. This is with number, but you can do also that in a most general way, just with letter, okay? So this 2 is because it's the Unilever requirement in the case of wine. Okay, and here we have the 1 that is the Unilever requirement of cheese. And now it's really easy because we can say, okay, if the quantity of cheese is 0, here 0, what is the value of wine? Is 120 over 2, so 60. So cheese is here, wine is here. If cheese is 0, so that means we are here in the middle, because a high value of cheese is going to the right side. But 0 is here, and this is for, this is for wine. So that means that wine is going to be 60. So it's that point, because it's that combination of values. And vice versa. Now let's take a look at the same expression, but now isolating in terms of quantity of cheese. So here's cheese, this which is with a positive sign goes to the other side with a negative, that's why we have this value here, and this which is multiplying now is dividing here. This is just with letter, but it's the same thing. So now we can say if the quantity of wine is 0, I know now the quantity of cheese is 120. So if wine is 0, 1 is in the vertical, so 0 is here. The other one is 120 is this value. And with these 2 values, now I can make the whole line, okay? So now we have the PBF, is this one. That is the PBF. How do we can make the slope of this curve? I mean, the slope or the opportunity cost of producing 1 unit more of cheese, which is the absolute value of the slope, okay? The slope in absolute terms. So you can use the way that I saw you previously, just taking 2 values, okay, from A to B. It's the same methodology that I applied before, but now I'm going to use a different way, okay? Because now I have, here it is, I have a function, well, in different ways, in different versions, okay? But it's the same, okay? This is the same as this, but here is with L outside in one part, here is with the quantity of wine, and here is when you are isolating the quantity of cheese, but it's the same expression in different ways. So I'm going to do the slope using the derivative. That is the thing that I prefer. The notation, we use a specific notation to do that. Is just remember the slope of something always, and this is important, is how this changes when this increases in 1 unit. Okay, always is in that way. So, how is the way of putting that words in mathematical notation? In this way. How this is like the derivative, but for you it's like how change the quantity of wine when you change the quantity of cheese in 1 unit. Okay, you don't have to do now any kind of division. Okay, when you are doing the derivative, you don't need to do that. But you are going to put this and then you are going to resolve. How is the way of resolving this? You need this, this quantity of wine in terms of quantity of cheese. So you need to find the expression, the mathematical expression that connect both variables in this line, which is the PPF course. So, and this has to be is isolated, which is this one. Okay, here you have the quantity of wine respect to the quantity of cheese. So you are going to be able to know how this changes when this increases in 1 unit, because you have this in terms of the other. Okay, always has to be in that way. So this variable has to be isolated, like it's here. So now you know what is the connection between one and the other. How this can change the other one. That is the thing that you're looking for. In fact, to resolve that is just making the derivative. You have in fact, you can see that you have 2 terms, because this is also 120 over 2 minus the quantity of cheese divided by 2. 100 divided by 2 is 60, is a number, the derivative of a number is 0. So nothing here. Minus, nevertheless, we are going to subtract the minus later, but well, minus, and now we need to do the derivative of this, because here, this is our variable, okay? That is the thing that we are indicated. That is our variable, okay? So, I'm going to put that here. It's like 60 minus 1 over 2 times the quantity of cheese. It's the same thing. So you can see that this is the same thing of this. As I said, the derivative of this is 0. But now take a look at this. I put, instead of this in this way, in a different way. But this, what is this? This is a number. It's under or below the 0. It doesn't matter. Yeah, it's 0.5. It doesn't matter. It's a number. The derivative of any variable, 3x. The derivative of this, if this is equal to I, the derivative of this, so in our notation is like the derivative of y respect to x, it's just a number that is with the x, so it's free. Here is minus 1 over 2. Okay, that is the slope. Now in absolute terms with the positive terms. And what is the meaning of that? Is how it's going to change the quantity of wine when you increase the production of cheese in 1. So if you produce 1 unit more of cheese, that means you are going to produce 0.5 unit of wine less. It's going to, this negative sign means that when you increase something, the other thing is going to be lower, it's going to reduce. Because we are going to talk about opportunity cost, we already know that it's going to be negative. So as I said previously, the opportunity cost is without the sign. But because we know that that is the cost, the reduction of the other things that you are producing. Okay, so this 1 over 2, so 0.5 is the quantity in which is going to be reduced the wine, so 0.5 liters lower than before, if you introduce if you produce 1 unit more of cheese. And what is the opportunity cost of the other goods? So the opportunity cost of producing 1 unit more of wine it's just inverse number, so it's going to be 2. The meaning of that is, if you want to produce 1 unit more of wine, you are going to produce 2 units lowers of cheese, okay? Just inverse. So this is the opportunity cost of produce 1 unit more of cheese, the inverse, cheese over wine. I don't know if you are able to see that. So the inverse derivative is minus 2, in absolute terms is 2. So if you introduce 1 unit more of wine, you have to reduce 2 units of cheese. Now we are going to do the same analysis but in a much more general way. So instead of introducing numbers, let's skip the letter, where each letter have a specific meaning. So here we have our general expression in which we are observing that the whole labor is working. So because this labor can be in one of the two industries, cheese versus a wine industry, but the whole labor is used. That's why here we have an equal, okay? So it's the PPF. Because we can observe that the relation is always a straight line, so because we don't have any square over here, for instance, or any variable that is dividing, we can see that that is going to be, as I said, a straight line. So to get that, to be able to do that line, we just need 2 points. Which 2 points we normally are we going to use? The most easier points are these 2 points, the strain cases, as we observed previously. So my recommendation for that is, if you have this function, then isolate one of the variable, that is the quantity of cheese, and the other variable, the quantity of wine, okay, in terms of the rest of the variable. Here we have how this quantity of cheese depends on labor, and also it's going to depend in the amount of wine that you want to produce and the Unilever requirement in each sector. More specifically, we are able to see what is going to be the quantity of cheese when we are not producing wine. So if the production of wine is 0, we know that the maximum amount of cheese that we are able to get is going to be labor, the total labor in that country, divided by the number of labor that we need per unit of cheese. Okay, so that is going to be the maximum amount of cheese that we can produce when that is the case when you are using all your labor in the production of that cheese. Okay, where is that in this graph? Is when the production of wine, which is in the vertical, is equal to 0. So here, the quantity produced of cheese that is in the horizontal is going to be here. Okay, now the same analysis for the other points. So here we just have 1 point. The other is when we are isolating the other variable. Here we have 2 variables, quantity of cheese versus quantity of wine. Okay, so here is the quantity of wine, how it's connected with the other variables of the model. In fact, let's see what is going to be the quantity of of wine when the quantity of cheese is 0. So when we are using all our labor in the production of wine. So if this is 0, as in the same case, in the previous case, this is 0, 0 multiplied by any number is 0. So the final result is L over the Unilever requirement of wine. So the quantity of wine is going to be connected with the number of labor that we have in the economy and the technology in that sector, the Unilever requirement of wine. Where is that in the graph? Well, when the quantity of cheese is equal to 0, quantity of cheese is here, so equal to 0 is here. Keep in mind that here we have the 0, 0 case. Then the wine is going to be L over the Unilever requirement in the case of wine. So it's going to be this value. Okay? So this is a general way of observing how it's going to be the maximum amount of each production of each good when we are destinating the whole thing, our whole resource, that is in this case just labor, in one of the industry, and between is going to be the rest of the possible combination. Okay, so you can introduce any number, for instance here, and then you are going to be able to know the quantity of the other good. Okay, and this was just for getting these 2 points, and now you can make the whole line. Let's see now with letter the slope of this PPF curve. Okay, in the 2 ways, using 2 points as we saw previously, and also doing the derivative. But instead of using numbers, let's skip the letter and see then what is the connection between this letter and the opportunity cost. By using the derivative, we have to do this. Okay? It's not a division, as I said previously. For us, it's going to be a sort of notation. And the thing that we are saying with that expression is, I want to know how change this variable, this quantity of wine, when the quantity of cheese increase in 1 unit. Okay? So that is the meaning of the whole thing. It's really important, really, really important that you are able to understand that, to know that that is the meaning, and how is the way of getting the result of that. Okay? How is the way of getting the result of that? As I said, you need the expression where it's connected this variable with this variable, where this is isolated. So that variable, in this case, the quantity of wine, is depends on the quantity of cheese. So that's why I put that here, because that is the expression that we were looking for. So we have this general expression where it's connecting everything, but we want to know how is the connection or the relationship between the quantity of wine and the quantity of cheese. To get that, we need to isolate from this general expression the quantity of wine. Why? Because that is the slope, okay? How does this variable change when this increase in 1 unit? That is the slope. Here is wine, here is cheese, but it can be in the other way around. Always the slope is how change this variable, whatever is the name, respect to this variable. So we need to know what is the connection between these 2 variables, more specifically how this variable is connected or depends to the other, okay? So that is the relationship. Now we need to do the derivative of this, so of this expression, respect to which variable? Here we have many variables, but respect to the quantity of cheese. So we are going to assume that the other variable are going to be constants. So that means they are like number, and the derivative of a number per se is 0. So here we have this L divided by the Unilever requirement of wine. So this division is, the derivative is 0. And now we have our variable of interest, which is multiplied by minus Unilever requirement of cheese divided Unilever requirement of wine. So this is like a number. I don't know which number it is, because here we have just a letter. It can be any number, but it's a number, and the derivative of one variable multiplied by a number is a number that is with that variable. So this is going to be the slope of the function, where the slope of the function always is the opportunity cost of this variable, of the cheese. Why? Because the slope is how does it change this variable when this increase in 1 unit, and it's going to be negative, right? We are going to have a reduction because we are using all our labor. So that means if you want to produce more of one specific good, you have to reduce the production of the other goods, because for producing more you need more labor, and because you are already using all your labor, that means if you want to produce more, so use more labor in that industry, you have to take that labor from the other industry. So you are going to produce less of the other industry. That's why this slope is always negative. Okay, and it's the opportunity cost of producing more cheese, because you are producing less wine. Okay, So, something important that you need to keep in mind. The opportunity cost of cheese, of this variable, in this case is cheese, can be other. The opportunity cost of that variable always is going to be the ratio of the unit level requirement of that variable, cheese, divided the unit level requirement of the other, in this case wine. Okay, if I want to know the opportunity cost of wine instead of cheese, I know it's going to be just inverse value. So, how does it change? Cheese when wine increase in 1 unit is going to be just the inverse. Wine is going to be here, while cheese is going to be down. Okay? You can do just this, change the numbers, or you can take, instead of this function, the one where cheese is the variable that is isolated. Okay? Now we have done this using the derivative, but we can do the same analysis using 2 points. So we are going to get the slope of this curve taking these 2 points as we did previously. Now we are going to get the slope, the opportunity cost, but using 2 points. Previously we were talking about the slope. If you want to talk about opportunity cost, it's exactly the same but without the minus. Just keep in mind cost is already negative, so when we are talking the opportunity cost is if you increase something you reduce the other thing. So in a certain way we are saying negative signs there. There is a minus there, okay? So here let's say opportunity cost, so it's the slope but in absolute terms, so without the negative sign. But it can be this, if you're talking about the slope, it's with a negative sign. If you're talking about opportunity cost, it's the same value but without the negative signs, okay? So as we observe, now we are going to do the opportunity cost of cheese. So that means how it's going to change the quantity of wine when you increase in 1 unit the quantity of cheese. That is the opportunity cost of producing more cheese. More specifically, is the opportunity cost producing 1 unit more of cheese. How you are going to reduce the quantity of wine, okay? So to do that, you just need 2 points. So this is the other way to do the same thing. You need 2 points in which you want to see what is the effect in wine coming from the increase of cheese. So it's going to be going from a point A to a point B, because in the point A the production of cheese which is in the horizontal is 0, okay? Where here the production of cheese is higher. So that's why I want to observe how it's going to change the quantity of wine when I increase the quantity of cheese, okay? So how does it change wine when I change cheese? Final value minus initial value. Nevertheless, here it doesn't matter because we are going to subtract the negative signs, so it doesn't matter. The value, the distance is the same. Okay. So final value in the quantity of wine. Wine is in the vertical, so here the vertical value is 0. Okay. Final value B. The initial value, it is this one. So that's why we have 0 minus L divided unit level requirement of wine. And now, in the case of cheese, we are coming from this point to this point. Final value, cheese is in the horizontal, so as higher is the distance from here to here, higher is the quantity of cheese. So this is the final value, this one, which is this one, minus the initial value. In the point A, we are just here, okay? If we talk about the horizontal axis. So we are going to have that. You can see that this is negative, but because we are going to subtract the minus, you just keep the positive signs, divided by this value. So here we have a ratio of ratio. The way of doing this is this multiplying by this over this multiplied by this. That is the thing that we have here, okay? So this multiplying by this, divided this, multiplying by this. L and L is the same value, and because it's multiplying both over and down, you can eliminate that, it's cancel off, okay? So this once again is the opportunity cost of producing 1 unit more of cheese. You can do the same thing to quantify the opportunity cost of producing more wine, okay? The result is going to be just the inverse. So you can do it using these methods or just considering the inverse number, okay? Now we're going to see another interesting concept. We were talking about that concept, but just a little bit. Now we are going to see a little bit more or in more detail how we can get that value. I'm talking about the productivity of labor. The productivity of labor, we are going to see that in the case of cheese now, and then we're going to do the same thing but in the case of wine. What is the productivity of labor? What is the meaning of that? When we are talking about productivity of something, we are observing how it's going to change the production of that thing. In this case, we want to know how change the production of cheese, okay, when we increase in one the amount of labor. So that is going to be the productivity of labor. So it's how it's going to change this variable. Here is the quantity of change when this variable increase in 1 unit. You see that always when we have this, always is the same notation for the same intention, with the same, when we are looking at something that always is in a certain way the same. That thing is, we want to know how does a variable change when another variable changes. And that change, the variable that is changing in the first place, the quantity of that change is always the same and is 1. So I want to know how it's going to change that production of cheese when I have 1 worker more. We could expect that that result is always constant, like it's going to be in this case, but it doesn't have to, okay? So here we are going to get like a value, a number that in this case is a letter because we are using just letter, but you can do the same analysis with numbers. It's not going to be a function of this variable, it's going to be just a number. But it could change depending on any case, okay? In this chapter, always is going to be constant, okay? So, how is the way of getting that? How is the way of getting the production, the marginal production of labor, okay? Marginal is because it's for 1 worker more. That's why it's marginal, okay? So, to know that, to be able of getting that result as all as previously, we need to have a function in which we can connect both variables, where this variable is in terms of the other variable. So please think. So this is coming from this general expression where we are assuming that all the workers are working. They can be working here in the cheese sector, or they can be working in the wine sector, or a combination between these 2 sectors, okay? So to get that, we need to isolate this term. So that means this is with a positive sign, so it goes with a negative sign in the other side. So that's why L minus this, okay? And this, which is multiplying, goes to the other side divided. So now I have the connection between this variable and L. In this case, I'm looking for the effect of labor. So, but the next step is, okay, now this is the way how those 2 variables are connected. But I want something more specific. In fact, I want to know how it's going to change this when this increases in 1 unit. So I need to do the derivative of that. Respect to this variable. Now is not respect to this variable. No. Now the variable is going to be just L. So the other letters, it's like constant numbers, okay? They don't change. So to make a little bit easier this expression, we can separate these terms to these terms, and it's the thing that we have here. So L divided by Unilever requirement of cheese minus this part, which is Unilever requirement of wine times the quantity of wine. So it's like the number of workers in the wine sector divided the Unilever requirement of cheese, okay? The derivative of this, so here, from here to here, because here we have an equal, okay? To make things even easier. So we are going to have, instead of L divided by Unilever requirement of cheese, I separate that in a product. On the one hand, I have 1 over Unilever requirement of cheese times L. It's the same thing, okay? What I'm trying to do is to show you that this division, it can be seen also as a number times my variable, instead of a division. If I have a division, normally students think about the derivative of a division, but in this case you don't need to do that, because the variable is up, it's not down in this division. So that means you are able to get, instead of just a division, a product. 1 over that value times your variable, okay? And then minus the other part, okay? So this is going to be just the same. Now it's much more easy to observe that this is just a number. Imagine that this is 2, okay? 1 over 2 is 0.5, okay, it's a number. Or imagine that this is 0.5, so this is 2, okay, it's a number. It's a number times my variable. What is the derivative? The number that is joined to my variable. So the derivative is going to be, in this case, 1 over Unilever requirement of cheese. If you remember, we have been talking about that. We were talking about the Unilever requirement as a variable that sets the number of labor that I need per unit of cheese, in this case. And we were saying that as higher is that, it's because the labor productivity is smaller. If I need a lot of workers to produce 1 unit, it's because the productivity of each worker is really small. And vice versa. As far as I need less worker for the production of 1 good, it's because each worker is really productive. So its marginal productivity is really high. So that is the main conclusion. The marginal productivity of labor always is going to be the inverse of the unit labor requirement in that sector. We are going to repeat this analysis just to practice for the case of wine, and then we are going to do the same analysis but using numbers. Now we are going to do the same analysis but in terms of the marginal productivity of labor in the case of wine. So, as I said, to do that, the variable that we need to isolate is, in this case, the quantity of wine. And then we are going to have the connection between the quantity of wine, how that quantity depends on the labor, okay? Also, it depends on different variables, of course. No, it's not just labor. Also, it's going to be connected with the amount that you want to produce of the other good, of course. But now, the thing that we want to know is, given that the other variables are constants, so ceteris paribus, as we say, given the fact that the other variables are just a number and they are not going to change, I just want to isolate the effect of labor. In fact, I want to know what is going to be the effect of 1 worker more. Where? I want to see that effect in the case of the production of wine. Okay? So I need first this thing. Also, if you prefer, instead of observing this whole thing, just something together, you can separate terms. So here, because it's the common, the denominator, you can separate these 2 terms. And then also, you can see like L divided by Unilever requirement is the same thing as 1 over Unilever requirement in the case of wine times workers or labor, okay? So then, when you are going to do that derivative, so how is going to change this variable when this increases in 1, you already know that the variation of this is 0 because all of them are constant number. Your only variable now of interest is that one, so this one. And then you also know that this is a number, so the derivative of a number times your variable is just a number which is joined to that variable. So here we have the unit labor requirement of wine. In fact, the inverse number of the unit labor requirement of wine. So as I said, it's going to be connected with the unit labor requirement, but in an inverse way. As higher is the unit labor requirement, that means that the productivity of labor in that sector, given the current technology in that economy, is inverse. So as higher is this one, lower is the marginal productivity. Now we're going to do the same thing, but using the number that we had previously. So here there's going to be a number, we are going to have a number also, and a number. Sorry, we are going to keep this like, instead of a number, we are going to keep that like a variable. Why? Because we want to know what is going to be the effect of increase that variable. So that is going to be one variable for us, while the other things are going to be numbers. So we know that the unit labor requirement of cheese is 1, so we can put that value. The unit labor requirement this is for cheese and this is for wine. We are going to keep the other like variable. Nevertheless, we are going to know that sometimes some of them are going to be constant. For example, when we want to see the marginal productivity of labor in the case of cheese, we need, as we said, to isolate the quantity of cheese to see how it's connected and how this affects to the other variable. Now this is going to be constant because the only thing that we are going to consider as a variable in the right side of the expression is going to be that, the one that is indicated in that. That's why it's really important to have a notation where we are specifying which of the possible variables are going to be actually our variable. So in this case it's labor, so it's like this is a constant. And the other, we already know the number of those variables that now are constant. So the derivative of this is going to see that, well, this is the derivative of this is 0, and here we have L divided by 1. So it's L. The derivative of L respect to L is 1. So that means if you introduce one worker more in this industry, you are going to get 1 unit of cheese more. Okay, so that is the result. Now let's do the same thing, but considering the wine industry respect to the unit labor that you introduce in that industry. So we need to isolate these terms. Now we can do the derivative because we have this variable in terms of this variable and other variables, of course. And this is going to be like constant because the only variable that we are going to consider as an actual variable in the right side of the expression is going to be just labor. So just keep in mind that this can be also be written as 1/2 times L minus the quantity of cheese over, in this case, 2. Okay, so the derivative, this is like a constant variable, so its derivative 0, and here we have a number times our variable. So it's just a number, 1/2. Okay, so now we have that if you introduce one worker more in the wine industry, you're going to have 0.5 units more of wine. Okay, that is the result, that is the conclusion of this. If you're not really sure about how make a derivative, you already have in our Aula Virtual one document with some rules of derivatives, okay, the main ones. Actually, we are going to do really simple derivative. Basically, all of them are going to be this kind of derivative. But in that document, you even have more different cases, more complicated than this one.